Yeah, good evening and hello to everyone. Welcome to this live interactive session for the course Integrated Waste Management for a Smart City offered through NPTEL. My name is Sedu Vinayagam. I'm a PhD scholar in the Department of Civil Engineering at IIT Madras, and the purpose of conducting these live interactive sessions is to help the learners and students in this course to be able to solve the weekly assignments that are released for this particular course. So, what we will be doing in these sessions is we'll have a set of sample questions that will be based on the contents for of the lectures covered in each of the weeks, and then see what are the concepts behind those questions and how to go about answering them. So we will have one session each week for a duration of about 1 hour. So we'll meet at the same time on each week and in the same platform, and and then we will discuss any doubts if you have, and then also look at some of the sample problems, as I said. So these will help you to solve the assignments that are being released each week for this course. All right. So before we get started with this session, so I would like to just know how many of you just looked at the lectures for this particular week, and also if you attempted the assignment for this week. So I'll just launch a poll, so you can go and answer in the poll. Yeah. So we have a couple of sessions for this particular course. So we have one on Friday, 6 to 7 p.m., and one on Saturday from 5 to 6 p.m. So these two sessions, so you can attend either of these two sessions as per your convenience. So if you are fine with Friday, you can join this particular session, or if you are free on Saturday, you could join on the Saturday session. Yeah, it will be more or less. And we'll be discussing about the content that was covered in the lectures for this particular week. So we will be discussing the same concept. So depending upon your convenience, you could join either session. All right. So I see only 11 votes on the poll. So what about the others? Are you able to find the poll? So if you look at the activities button in your Google Meet. So the small icon with a triangle, square, and circle. If you click on that, you will be able to find the polls option, and then there you will be able to answer the poll. Yeah, Arun, do you have a question? Yeah, if you have a question, you can either put it in the chat or you can unmute yourself and ask. Okay, from what we have from the answer so far, most of you have partially went through the lectures. That's good, and some of you have not gone through it. That's totally fine. We will anyway. We'll still explain how what are the concepts, and but I would recommend you to watch all the lectures beforehand, and also to attempt the assignments also on your own, so before the live sessions that we have on each week. So that will help you to understand it better, and also you can have doubts if you have that can be clarified in these sessions. All right, so what about the assignments? Have you attempted the assignments? So week one assignment was also released. Did you guys go through that? Okay, so many did not attempt the assignment yet. That's fine. So I hope the deadline is not yet over for submission, so you'll still have time to do it. So yeah, so you can try it after this. All right. So we will get started. So before we look at the questions, so we will just have a quick overview of what was covered in the lectures of week one. So we had five lectures in week one, and lecture one covered some basic definitions, and we looked at some of the components in dealing with waste management, and also a little bit of history behind it. In lecture two, we looked at what are the different elements that are present in a waste management system, right? Right from uh, the generation of waste up until its disposal. There are multiple elements of it, so which was covered in the lecture two. And in lecture 3, we looked at the present state of, in terms of the global scenario, how waste is being handled, and what are the strategies that are being used across the world, and also what are the issues that arise or that stem from improper waste management. And then moving on to lecture 4, what we were introduced to this concept called as an integrated waste management, right? It had four components or four blocks of or strategies of managing the waste. So we looked at source reduction, recycling, and waste to energy in lecture 4, and then the landfilling was introduced to us in lecture 5. So these, with this overview, what we will do is look at the questions that are based on these topics that are covered in week one. So the question one is here. So the format of the questions that we'll be looking at will be similar to what you will face in the assignments, right? So it will be mostly multiple choice and multiple select type of questions. So we will follow the same format that you will be having in your assignments. So the first question is, which of the following is the de facto choice for waste management? And we have four options here: composting, incineration, landfill, and recycle. So all these four are ways of managing waste, solid waste, right? So these are all different strategies that we could use. But the question is, what is the de facto choice, or the most preferred or the most used choice for waste management? So if we look at that, so what happens in these different strategies that we have? So we have composting. Uh, Yeah, composting is the natural decomposition of organic solid waste, right? So, and in incineration, what we do, we combust the waste to transform it into useful energy that we could use for other processes. And then in landfill we just uh, dispose the waste, right? So if we can't do any more process or any useful recovery from it, so ultimately the wastes end up in a landfill. And finally, in recycle, what we do, we try to reintroduce the materials that we have already used in the products that we use back into the production process, so that we don't have to use new materials every time, right? So out of these, the most used choice for handling the waste is the landfill, option C. And so we have this little infographic here that tells us why is that so, right? So what we see here is these little triangles. So what they have four different components. So the top part shows the per capita waste generated. The second part is the rate of recycling that is being done with all the waste that is generated. The third part is the number of waste to energy transformation facilities that are being in use. And the last part is the disposal, or the amount or the percentage of waste that is going to the landfills. And what we see across the world,
हेलो हेलो सर
yeah,
सर
yes,
सर एक डाउट है सर
yeah, go ahead. Okay, so what we see in this infographic is that in most parts of the world, the major portion of the waste that is being generated is going to the landfill. We see 100%, 100%, 191% in India, and so on. So a lot of these waste that is being generated is going to landfills. So a very small amount is only being handled by other strategies such as the energy recovery or the recycling. Except in say in the European countries and in the US. So we have a relatively lesser portion going to the waste, but still it is not zero, and there is still a considerable portion that is being going to the landfill. So which is why we say that the de facto choice for the waste management is being landfill. Whether it is preferred or not is a different case, but that is what the present state of managing waste is. Okay, any questions with respect to that? What we have?
No, sir.
Okay. So we move on to question two. Which of the following represents the negative impact associated with the incineration of municipal solid waste? A. Large volume reduction. B. Air pollution. C. Potential energy recovery. And D. None of the above. So if we looked at incineration as one of the ways of handling waste in the previous question, right? So, but it is not totally a clean solution or a totally a solution with only pros. It has both pros as well as cons associated with it. And here we are looking at what is the negative impact that is associated with incineration. So if you look at the options, we have option A is a large volume reduction of the waste, which is not actually a bad thing, right? So it is not a negative impact. So we'll just leave that. Moving on, so we'll leave B for now. In looking at C, potential energy recovery, again, that is not a negative impact that is associated with it. If we recover energy, we could use it for other purposes and processes. So that's also not a negative impact associated with it. So only B, air pollution, is the negative impact that is associated with incineration. So when we incinerate or combust the waste materials, right, it is not going to be completely transformed into heat, right? So there is going to be some flue gases that is going to be generated from the improper combustion. So right, so it's not avoidable, and also so that is going to pollute the air. So that's why option B is the correct answer to this question. And air pollution is not the only problem that is associated with incineration. That it has some other negative effects as well. For example, the waste stream that we are feeding it to the incineration plant, right, it may not always contain combustible items, so there will still be some non-combustibles in it. And also there could be ash that will result from the incineration of this waste, which will still require to be disposed in a landfill. So we cannot completely eliminate the disposal part by just incinerating. So though the volume is going to be reduced, there is still going to be some residue that needs disposal. And also there will be still issues remaining for finding sites for these incineration factories, right? So the issues that exist similar to finding a site for landfill also exist for these incineration facilities. So these are some negative impacts that are associated with incineration. Okay, any questions with that? Yeah, Amit, go ahead.
Hi, Setuji. My question is that's it's this is a technology. The waste to energy and incineration is a technology
Hmm.
which reduces the waste.
Yeah.
And like if you talk about the coal plant, also thermal plant, they also have the ash. So
Hmm.
we can't consider ash as a negative impact of any technology. But yes, if you talk about the air pollution, as per my thinking,
Okay.
as per my like, if you talk about the air pollution and flue gas, they also have the flue gas cleaning system. That is the another thing that at what level they are treating that thing flue gas.
Hmm.
But yes, they have the flue gas system. Bags are also there in the cleaning part. So how we can consider the air pollution is a negative impact because pollution control board and other bodies are also allowing that plants to
Hmm.
set up in the metro cities also.
Hmm.
So how we can say that it's a negative impact? The like if they follow or not, that is a different thing. If
Hmm.
someone want to save money, But yes, how we can say that they are doing the air pollution and all if they are having all the cleaning system and other things to control all the flue gas, vaccine free roams, everything.
Yeah, so it is not about whether they are following it, following the norms and the legal procedures, and whether they are sticking to the standards or not. Even if they do all that, there is still going to be some of these flue gases that are going to be still released, right? So it's not about whether you are following it or not, whether it is going to impact the environment, right? Even if you strictly follow
Okay,
the standard, it's going to still cause environmental issues, right? It's going to affect the environment and ultimately the health of humans and other animals as well. So it still has a negative impact in that aspect. So whether even if you strictly follow these standards, it's
okay,
still
okay,
going to have some damaging effects.
okay, sir. Okay.
All right. Okay, so we have question about how is incineration performed. So incineration means to combust or to burn the waste materials, right? So we have two major ways of converting it. So one is you could directly is called the mass burning. So where you will try to first separate out all the non-combustibles to the extent possible, and then you try to burn it directly. So you have these incineration plants, so where you have these uh, the waste is fed onto say you'll have something like a conveyor belt, so and with grates, so where air will be supplied, right? So you need, because you need oxygen for incineration, and then these combustible materials will then be burnt in that chamber, and the heat will be recovered from this chamber for steam generation and then electricity from it and so on. And there'll be still some residue which will be sent to the landfills. So that is one way. The other way is to shred these waste materials into smaller pieces so that we can handle them better, and then convert them into something called as a refuse derived fuels, right? So these will be like small pellets, so which we can then burn in other processes, not immediately, but we can then later use it for burning and then generating heat from it at a later point in time. So these are two ways in which incineration is performed. Okay, so with that, we'll move on to the third question. According to the Environmental Protection Agency, what percentage of the waste quantity can be reduced by source reduction method in a solid waste management? So we have four options: 100%, 15%, 10%, and 50%. So the correct answer to this is, according to the EPA, it is about 50% of the waste can be reduced if we do a source reduction. So what do we mean by source reduction uh, is handling the waste at the source or the at the generation point itself, right? So where we are using the product at that stage itself, if we try to minimize the waste that is being generated, so that is what we call as source reduction. So to use lesser materials in the first place, so that the amount of waste that gets generated is reduced. So according to EPA, by doing that, we can reduce up to 50% of the waste in terms of the volume we can reduce, and in terms of the weight of the waste, it is up to a one third of the waste weight can be reduced by doing the source reduction. So how do we do that? By doing substitution. So we try to use smaller, lighter, and degradable materials in the production on the manufacturing of products. So what we look at is uh, the packaging materials that we use currently, so they are contributing to a large component of the waste that is being generated, and we are using a lot of the materials for these packaging. So if we try to substitute that with smaller, lighter, and more degradable materials, we can more easily reduce the waste that we generate. All right, so any questions with that? Oh yeah, we have a comment in the chat. So by using good quality materials, which by which we could sustain or prolong the useful life? Yes. So that is in the actual product that we use. If we make them more durable, so then we could prolong the useful life. That way, it is not going to become a waste soon. But the packaging materials are not going to be useful again, right? Once you open the packaging, so it's not going to be of much use again. So in that case, it's not logical to use more durable materials for packaging, because anyway it's going to be of no value to most people once it is open. So in that case, we don't want to be having more durable materials for that. But for the actual product that is of use for the end consumer, that we can make it more durable so that it doesn't become a waste.
Got your point, sir.
All right. Moving on to question 4. So here we have two columns. So we what we want to do is match the options given in column 1 to those in column 2. So we'll do a bit of a quiz here. So I'll create a poll again, and you can type in your answer, which is the correct option. Okay, A, B, C, or D. So try to match the terms in column 1 to those to the description given in column 2, and you can put your answer in the poll. Okay, there are only 8 votes so far. Um,
We have to give the answer in that.
yeah, yeah, you have to answer it in the poll.
It's kind of is it C?
We'll see it first.
Okay,
I'll wait for
okay,
everyone to answer. Yeah.
okay. Sorry.
Okay, there are only 11 votes so far. What about the others? Are you able to find the poll? Yeah, for the others who joined late, I'll just reiterate. So if you look at the activities uh, button on your on your bottom right, so that it is this icon with a triangle, square, and a circle. So if you click that, you will be able to find the polls option, and within that you can put your answers in there. Okay, so far we have got a decent amount of votes in the poll. So there is a tie between options B and D. All right, and a few have answered A and C as well, but the majority have answered B as well as D. Okay, so we look at the answer now. So the correct answer is actually B. So we have disposal, which is the least favored method in terms of SWM. SWM is the abbreviation for solid waste management, and out of the different methods of or strategies of dealing with solid waste, so the least preferred or the least favored method is disposal, and two is the transformation of waste, which can be done in terms of incineration and composting. So we try to transform waste uh, from its original form into other forms. So that is done through different ways. One is incineration, other is composting, and finally, waste minimization is to use optimum resources and energy. So why is disposal the least favored? Because if you recall the waste management hierarchy, right? So this small triangle, so where we had four different levels. So if you look at that, we have different components in it. So or we call this as the four R's. So what is stand for are the reduce, reuse, recycle, and recovery or disposal. What is the most favored way of dealing with them is to reduce, or the source reduction that we saw. So we want to generate less waste in the first place, so that we have to deal with less waste, right? So that is the most preferred way, and the least preferred way is to not do anything with it and just dispose all the wastes, right? So that is not the best option that we have. So we are going, because this requires a lot of land area, and also there are other negative effects that are associated with it, right? So we have air pollution, soil pollution, and water pollution. All this can arise from the landfills. So that's why it is one of the least favored method of dealing with wastes. And with respect to transformation of waste, so we looked at this incineration and composting. So we saw again how incineration is used to convert waste from waste to energy, right? So it reduces the waste volume of the waste, and also gives us useful energy. So that way we are transforming the waste into useful energy. And in composting, what we do is composting is used to deal with organic waste. So we use natural decomposition process to convert this organic waste, so that it could be used as, composts, as fertilizers, and so on. And finally, what we mean by waste minimization is to have to use lesser energy, and also to use lesser material when we are trying to in the manufacturing processes and in the production processes, so that we are not generating more wastes in the first place, right? So that is what we mean by waste minimization. So the correct match is given in option B. So any doubts with respect to this?
No, sir.
Okay.
Sir.
Right, so moving on. Question 5: which of the following is the drawback of recycling waste? So, again, recycling is one of the ways of handling waste, right? So, we have four options: save precious resources, improves the efficiency of composting, lowers the impact of mining, can result in superfund sites if poorly managed. So again, if you look at the options, the first three are actually not a drawback of recycling, right? So these are the advantages that we get of doing recycling of these wastes. So we save resources, we improve the efficiency of composting, right? We can separate the organic and the non-organic parts, and then recycle those non-organic wastes, and then leave only the organic waste for the composting. And also this will help us reduce the amount of material that we mine to for manufacturing or productions, right? So we can reuse materials from the waste, so that is going to lower the impact of mining. So the only negative aspect that is associated with recycling, that's from these four options, is that it can result in superfund sites if it is poorly managed. So what do we mean by that? So what are the superfund sites? It's a term that is used to refer to sites that are polluted or contaminated. So if we don't recycle properly, and then if we leave the waste, so it containing hazardous waste and other contaminants, and if we don't handle them properly and recycle them properly, then it leads to contamination of these sites where it is dumped finally, right? So and those sites are what are called as superfund sites. So and this improper management will ultimately result in contamination of both soil, water, as well as the air around this area. So that is a drawback that is associated with recycling. Okay, any questions or doubts? Okay, so someone has answered in the chat as well. It is option B. Yeah. Okay, if there is no question with this, we'll move to question 6. The liquid waste that forms in a landfill when water passes through is called dash. A, concentrate, B, leachate, C, seepage, and D, none of the above. This is just terminology that we use, right? So the description given here is actually what we refer to as leachate. So what do we mean by that is the residual contaminants, okay, that are present in this landfill sites. So when water is passed through this, so the water that is passing through will carry these contaminants, and that is what we call as a leachate. So when it leaches out these contaminants from these landfill sites and also leaks from it, so that is what is called as a leachate. And what is the problem with that is that it is highly toxic because it is carrying these contaminants, and also it is highly odorous. So it is so that is not a pleasant thing to have, right? So these are the issues that we have with leachate. And moreover, it can also seep into the groundwater and also contaminate that. So the longer we let it or not deal with it, so it is ultimately going to reach the groundwaters below this landfill sites and ultimately contaminate it. And in some cases it can affect the surface water as well. That is the correct answer, option B, leachate. Okay, any questions?
No, sir.
All right. So question 7, which of the following gases are present in the landfill gas? So we have four options: CH4 or methane, O2 oxygen, CO2 carbon dioxide, and D, both methane as well as carbon dioxide. So yeah, we saw one of the end products, right? So one of that was leachate in the landfill site. So there are landfill gases which will also be produced, and the question is which of these gases get produced in the landfill. So the answer to that is option D. It is both methane as well as carbon dioxide. So why do we get these gases? Is because the solid waste undergo the anaerobic decomposition process. So the biodegradable materials in these solid waste will go through the anaerobic decomposition. There is not going to be oxygen supply because we will be covering these landfill sites. Because of that, there is going to be anaerobic decomposition that will be taking place, and the end products that is resulting from this anaerobic decomposition is the methane gas as well as the carbon dioxide gas. I think that is a straightforward one. Okay, any questions?
No, sir.
All right. So question 8, what is the primary advantage of using a liner in the landfill? So option A is it prevents seepage into the underground layers. Option B improves the efficiency of the degradation process. Option C, it prevents the odorous gases. Option D is none of the above. Yeah, yeah, we have answers in the chat as well. It is option A. So what do we mean by a liner? It is a barrier layer, right? So we have a landfill system, a landfill site. So on the sides and also on the bottom of these landfill sites, so we'll have what is called as a barrier layer. So that is the liner. And what is it made of? It is made of different materials that are going to have a very low permeability. So the purpose is to not allow the leachate that we saw in the previous question a couple of questions ago, right? So the purpose is not to allow that leachate to get out of this landfill area, right? So that we have this low permeability layer, and it is made of different materials such as compacted clay or geomembranes or the plastic material, or it could be a combination of these compacted clay and geomembrane, so that we do not let this leachate to seep into the underground layer and contaminate the groundwater. Okay, the other two are not the functions of using a liner, right? It's not going to help in degradation, or it's not going to prevent the gases or the odorous gas from forming. Its primary purpose is to prevent the seepage of the leachate into the underground layer. So we have Madhur has said like we could think of these as plastic sheets. Yes. So, but not just plastics. Yeah, it helps to think of it that way. But it could be made of compacted clay as well, right? So the purpose is to not have any porous layer, right? So we want the leachage to be retained uh, above this bottom layer of the landfill. Okay. Sandesh, do you have a question?
Sir, in previous question, there is oxygen. Sir, oxygen may also uh, can be present by landfill.
uh, Oxygen, yeah, some oxygen could be trapped in, but it is not going to be in a huge amount, right? So there will be a little bit of oxygen which could be trapped, but it is not going to be there in huge quantity. It's not a landfill gas. So what we mean by a landfill gas is the gas that is getting produced as a process of this anaerobic degradation. So it's not going to be produced as a result of the wastes that are present in the landfill. So we do not call the oxygen to be a landfill gas
Okay, sir.
because it's not produced from the landfill. Okay. Any other question? Okay. If there are no other questions, so we'll move to question number 9. The assessment of the environmental impacts associated with all stages of a product's life cycle is called dash. Option A, environmental impact analysis, life cycle impact method, life cycle analysis, and none of the above. Okay, so the answer to this is actually option C. It is the life cycle analysis, right? So what do we mean by a life cycle analysis is, so if you look at but if you look at any product, it's going to have multiple stages. So the first stage is the production stage, right? Once it is produced or manufactured, it goes into the consumption stage, so where we use the product. And once its usefulness is once it becomes not useful for us, it goes into the end of life, or the end of life stage, where we try to dispose it of, right? So there are these different stages that are associated with respect to products. So this is what is called as a life cycle, right? So what do we mean by a life cycle analysis is we try to look at what is the environmental impact, how much energy is being in the different stages of the product, and how much waste is being generated in the different stages, right? So there'll still be some waste that is generated in the production of a product itself, right? There'll be some materials getting wasted there, while during the consumption we'll be generating some waste, and finally the whole product is going to become obsolete, and it's going to end up in the waste. So there, if you look at this, all these different stages in a holistic manner, that is what we call as a life cycle analysis. But traditionally, what we were doing is we were only focusing on this right hand side, which is only at the end of life. Once the product is not useful anymore, right? Once it goes into the waste, that is when we were concerned about it. But it is not enough to just look at that. We'll have to look at we'll have to look at the whole life cycle of the product, so that we'll have a better understanding of what is happening in the waste in a product's life, so that we'll be able to better manage it. And so that is what we call as a life cycle analysis. Yeah, was that clear?
Yes, sir.
Okay. So the questions that we saw so far are the multiple choice questions. So where only there was one correct answer out of the four options that we had. And the questions that we'll be looking at from now on is of the types multiple select questions. So where we can have more than one correct answer to these questions. So there could be one or more than one answers that are correct. So question 10, which of the following are the advantages of source reduction in waste management? So we saw source reduction as one of the strategy of waste management, and which of these four options are the correct are the advantages of it? So option A is increase the useful life through durability. Option B is decrease the useful life through repairability. Option C, increase the energy usage in the product manufacturing. And option D is reduce the material use in product manufacturing. So again, if you look at these options, so the advantages that are brought by doing the source reduction strategy is options A and option D. So by doing source reduction, we talked about this in one of the previous questions, right? Uh, one was to use lesser material, right? And when we are producing we are producing the items, right? So in terms of the packaging material, we talked about how it is not being useful, it's not having much value once after it is after its purpose is done, right? So in that case we want to not use more materials in manufacturing it, right? One, because it's anyway going to end up in waste. So that is one advantage, so we try to use lesser material. The other is from the actual product itself. So if you make them durable, its life, its useful life is going to be longer, so we will be using it for a long time before we throw it out, so that we will not be using so that we will be generating less waste. So those are the two advantages that is coming out of these two productions. As BNC is not really an advantage, right? It's like saying it is, it's putting it in a negative aspect. So it saying decrease, option B is saying decrease the useful life through repairability. So we will not be decreasing the useful life when we are doing repairing, right? So by if a material is repairable, it's only going to increase its useful life because we could repair it and use it again. So option B is not a correct option. And C, increase the energy use in product manufacturing. Again, it's not the purpose of source reduction. We try to reduce our energy use, so we are not trying to do that in source reduction, and it's definitely not an advantage. So it's only options A and D which are the correct options. Any doubts?
No, sir.
All right. Moving on to question number 11. What are the different methods of energy recovery from incinerators? So we have four options: heat, cogeneration, potential energy, and electricity. Okay, so
D and D.
yeah, so I'll just create a poll. So I think this was covered in the lecture as well. So let's see if you can recall what are the correct options. So I'll just quickly create a poll that you can use to enter your answers. Okay, so since this is a multiple select question and the poll you could only answer one, so there are three correct answers here. Okay, so there is only one wrong answer. So in the poll, try to put which is the wrong answer.
Already did for one right answers.
It's okay. That's fine. So we don't have many votes right now. So people, you can put in which is the wrong one out of these four. Since the polls allow only for selecting one option, you could select the wrong one here.
Feel energy is wrong.
Yeah. Uh, yeah. What do we mean by cogeneration? It is generation of both heat as well as electricity together. So it's not one or the other. In a single plant, we'll try to generate both heat as well as electricity, so that we try to recover as much energy as possible from the waste that we are trying to transform, right? So when we are trying to only say produce electricity, there's going to be some heat that is going to be lost, that we are not going to be totally using it, right? So what we are in cogeneration, what we do is try to use all the energy that is being generated. So whatever is the residual heat that is left, which will also be used, and also the electricity will be generated from it, and that will also be used. So we are minimizing the amount of energy that is lost from these incinerators. Yeah, Syed, do you have a question?
Incineration is just only combustion or along with any process is there, sir?
It is mainly to combust these wastes. So either we can yeah, in incineration we just combust these wastes. So either we could do it directly, or we could even uh, yeah, it's about combustion only. So if you want to just convert it into a useful form of energy, so we need not do incineration directly. We can convert it into a different form of a fuel which could be later used for combustion. That is called as a refuse derived fuel. But when we say incineration, it is about combusting the waste.
Yes.
All right. So the initially people try to answer the pick one of the correct answers. So we had some answers for that, but after that, yeah, most of you selected option C, potential energy, which is not the correct answer, right? So all three, option A, B, and D, is possible from incineration. So we can generate heat, electricity, or both heat and electricity together, which is called as cogeneration. All right, so moving on to question number 12. Which of the following are the problems associated with landfill gas? So we saw two landfill gases, right? Carbon dioxide and methane. So what is the problem that is associated with these gases? So option A, it is non-toxic. Option B, toxic. Option C, it's combustible. And option D is odorous. Yeah, so people have answered all the three, B,
B
C, and
and D. B, D, C.
yeah, so all the three B, C, and D are correct answers. So if you look at them, so methane is both odorous as well as combustible. Whereas we look at carbon dioxide, it's not combustible, it is not odorous, but it is toxic. Especially if you look at high concentrations of carbon dioxide, it is toxic, and so that's why it's all the options B, C, and D are correct. Yeah, Syed.
Sir, landfill gas is nothing but biomass gas, right, sir?
No,
So the
not
gas will
just
be
methane. Carbon dioxide is also a landfill gas.
Okay, sir.
Yeah. Any other questions? Okay, so there are no other questions. We'll look at question number 13.
What is
Yeah, say it.
the source of the landfill gas? What
Uh,
is the
s- yeah, sources, as we looked at earlier in one of the question, it's a result of the anaerobic decomposition. So there are these biodegradable materials that are finally present in the landfills, right? So these biodegradable materials will undergo the anaerobic degradation, and as a result of this anaerobic degradation, we get these landfill gases.
Okay, sir. Thank you.
All right. So question 13 is about the liner material, right? So for the landfill liners, which of the following materials are used? Option A is sand, option B is clay, option C is geomembranes, and option D is glass. So as we saw earlier in one of the questions, right? So the
C.
yeah, geomembrane is one, and also we use clay. So clay as a material, but we do not use clay as such. We compact this clay so that we reduce the permeability of it. So, but the question is about the materials here. So it is both clay as well as the geomembranes, right? So the compacted clay can be used as a liner layer as well as the geomembrane. Uh, we Sand is used in the system, but its purpose is not as a liner material, right? Sand is used so to allow the percolation of the leachate from the landfill into our drainage system, right? So that's where we use sand. So sand is used in the landfills, but not for the liners, and we do not use glass in the landfill side. So the correct answer is only options B and C. So we could use either of them or a combination of both clay as well as geomembranes. All right. Any questions?
No, sir.
Okay. So question number 14 is which of the following are the removal mechanisms of leachate from the landfill? So we have four options: drain by gravity, B is blowing, C pumping, and D siphoning. Yeah, you can put it in your chat. Put the answers in chat.
We
Which
are pumping.
sorry.
It can be a pumping. I think pump. We have to
Okay.
pump the leachate to the leachate treatment plant. Then
Yeah.
we have to clean that.
Any other mechanisms? So we have four options. Pumping is correct. Okay. But what about the other three? Is there anything that can be done? Yeah, we have some answers coming. Yeah, so everyone is agreeing that A is one of the correct answers, right? Drained by gravity. Okay, we have C also is one of the options. D is also chosen by most of you. Okay, any other answers from anyone? Okay, so the correct answers are only options A and option C. It's both drained by gravity as well as pumping. So these are the two mechanisms that we use for removing the leachate. So what do we do in a drain by gravity? So what we do is this: we have this liner layer right at the bottom of the landfill. So these liners are not liner layer is not going to be a flat layer. It's going to have some slope, typically from 2% to up to 8% slope will be there. And what this allows is that, so on top of this liner we have this leachate collection system. So from the landfill, the leachate will be percolating into this leachate collection system. And because of the presence of the slope and because of the effect of gravity, this leachate that is getting collected is going to be drained by gravity ultimately to this drainage pipe that we have here, from which we will take it out of the landfill. So that is one way in which we remove the leachate, right? So by using gravity. And the other way is to have pumps that will be present within the landfills, right, at the bottom layer of the landfill, and then the leachate will be pumped from using these pumps out of the landfill. So those are the two ways in which we could remove it, but the pumps are not that much preferred as to the mechanism of draining by gravity. So if we can, we should try to do draining by gravity so that it is more efficient, or because there could be issues associated with pumping, right? So it could get cloud, or if it gets goes out of operation, then we don't have a way to, it's not very easy to access it, right, once we have closed it. So it will become very messy to deal with that. So therefore we should prefer drain by gravity. Yeah, Amit, do you have a question?
Yes, sir. I have one question, sir. Like drained by gravity is kind of that is the design of a landfill to so that the leachate can get to the one side or where it is. It can be 3 to 4 area where we can put the slope of 2 to 8%. So that is the design where leachate get collected to one area or another area. But for removal of that, only I think pumping is the only thing that we can pump that leachate to the like any level to make it available to the leachate treatment plant. So, like that's what my question is. That only the drain by gravity is a kind of design of the landfill.
Uh, yeah, like we need not have a pump along with the drain by gravity. We could design it in such a way that the drainage directly leads to a leachate collection that is outside at a lower level, outside of this
But sir,
landfill system.
always the landfill always we used to go to the minus level. Always
Mhm.
maximum 90% of the landfill are into the minus level so that the burned and other thing can and the more volume can be
Yeah, I see
accumulated.
your point. So finally we'll need a pump that is, even if we collect it from this leachate collection system, even if it is taken outside, finally we are going to use a pump to take it out. But when we look at just to take it out of the landfills, right? So in that case, we could use both a drainage through gravity, as well as we could directly pump it from inside it. So we need a pump outside finally from the collection pit, right? So to wherever we are going to treat the leachate, so there we will need it. but here we are only talking about to take it out of this landfill area. So for that purpose we could use gravity, that is enough, or we could use pump also.
Okay. Okay.
uh, okay, there is a question on the chat. Will we give a slope to the soil under the liner? The soil under the liner is we are not going to be worried about the soil under the liner, right? So we are preparing the liner. The liner is going to be the bottommost point of our landfill site, right? So we compact this liner layer, right? And the soil below it is going to be the natural soil, whatever is there. So we are not going to be worried about that part. So only this liner layer is what we will be designing it to have a slope, so that it enables the leachate that is coming on top of it is getting drained. So the soil beneath it is not is not necessary to have a slope, right? So we are not going to be worried about that, because the purpose is not to allow the leachate to reach that point, right? So the slope there is, giving a slope there is not logical, right? So it should not reach that point in the first place.
What is siphoning, sir?
Siphoning is when you transfer a liquid from one level to another level, right? So that's what we call as siphoning. So when you have say water at two levels, right? So one at a lower point and a higher point, and you try to transfer it from the higher to the lower end, so with a pipe. So that's what we refer to as siphoning, to transfer it. So here we do not do that. Yeah, because of the difference in the pressure level. Yeah.
Without using pump, right, sir?
Sorry.
Without the usage of pump.
No, no, no. All right. Any other questions? So this is the last question for this particular session. So we will stop here for this week. All right. So I hope some of your doubts got clarified and the concepts became more clear. So you can attempt the assignment one, and if you have more questions or more clarifications that you need, you could use the discussion forum as well to post your questions, and it will be answered there. Again, so we will meet in this same timing, so 6 to 7 on Fridays. So next week we'll be looking at the concepts from the lectures of the next weeks, right? So that is how we will do it. Okay, so if you have no further questions, we will stop the session here, and we will meet again next week. So I'll wait for a couple of minutes, so if someone has a question, they can stay back, or otherwise we can leave. Thank you.
Thank you, sir.
Thank you very much for the class, sir.
Yeah, thank you.
Thank you, sir.
Could we get your email so that in case we have any